Electrical panel upgrades are essential for ensuring the safety and reliability of electrical systems in homes and buildings. A panel upgrade becomes necessary when the existing panel is outdated, damaged, or insufficient to meet the current electrical demands. Upgrading enhances safety by providing modern circuit breakers and ground fault protection, reducing the risk of electrical fires and shocks. Firstly, consider the existing electrical load. Calculate the total amperage required by all appliances, lighting, and electrical devices in the building. This calculation determines the appropriate size of the new panel. Secondly, evaluate the physical space available for the new panel. Ensure there is sufficient clearance and accessibility for installation and maintenance. Consult local electrical codes and regulations to comply with safety standards. Thirdly, identify the main service entrance. Determine whether it needs to be upgraded to match the capacity of the new panel. A qualified electrician should perform a load calculation to determine the appropriate panel size. The load calculation assesses the total electrical demand, including lighting, appliances, heating, and cooling systems. It accounts for both continuous and non-continuous loads to ensure the panel can handle the expected electrical usage. When selecting a new panel, consider several factors. Choose a panel with sufficient breaker slots to accommodate current and future electrical needs. Opt for a panel with a high short-circuit current rating to protect against fault currents. Select a panel from a reputable manufacturer with a proven track record of reliability. Safety precautions are paramount during an electrical panel upgrade. Always disconnect the main power supply before starting any work. Use insulated tools and wear appropriate personal protective equipment, including safety glasses and gloves. Test for voltage to confirm that the power is off before touching any wires or components. The process of upgrading an electrical panel involves several key steps. Firstly, disconnect the power by turning off the main breaker at the service entrance. Then remove the cover of the old panel and carefully disconnect all the wires. Label each wire to ensure correct reconnection to the new panel. Install the new panel in the same location as the old one. Secure it to the wall using appropriate mounting hardware. Connect the main service wires to the main breaker in the new panel. Ensure the connections are tight and secure. Connect all the branch circuit wires to the corresponding breakers in the new panel, referring to the labels made earlier. Double-check all connections to ensure they are properly tightened and grounded. Install the cover on the new panel and turn on the main breaker to restore power. Test each circuit to verify that it is working correctly. After the upgrade, inspect the new panel regularly for any signs of damage or overheating. Replace any damaged breakers or components promptly. Keep the panel clean and free from obstructions. Schedule periodic inspections by a qualified electrician to ensure the panel is functioning safely and efficiently. Understanding electrical codes is crucial for ensuring a safe and compliant installation. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. Comply with all applicable NEC requirements and local codes. Obtain necessary permits and inspections from local authorities. NEC Article 220 provides guidance on load calculations for branch circuits, feeders, and services. NEC Article 230 covers service entrances, including the size and rating of service conductors and equipment. NEC Article 240 addresses overcurrent protection, including the selection and installation of circuit breakers and fuses. Grounding is a critical safety measure in electrical systems. It provides a low-resistance path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ground the panel enclosure to a grounding electrode system, such as a ground rod or water pipe. Connect all metal boxes and equipment to the grounding system using grounding conductors. Ensure that the grounding system is properly sized and installed according to NEC requirements. Bonding is another important safety measure that ensures all metal parts of the electrical system are electrically connected. Bond all metal enclosures, raceways, and equipment together using bonding jumpers. This creates a low impedance path for fault currents, minimizing the risk of electrical shock. Use listed bonding connectors and hardware to ensure reliable connections. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds their rating. Fuses are one-time devices that melt and interrupt the circuit when the current exceeds their rating. Select circuit breakers and fuses with the appropriate amp ratings for the circuits they protect. Install ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and other areas where water is present. GFCIs detect small ground faults and quickly interrupt the circuit to prevent electrical shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can cause electrical fires. RFCIs detect abnormal electrical arcs and quickly interrupt the circuit. Install RFCIs in bedrooms and other areas where arc faults are more likely to occur. When working with electrical wiring, use appropriate wiring methods and materials. Use listed conductors that are rated for the voltage and current they will carry. Install conductors in approved raceways, such as conduit or cable trays. Support conductors properly to prevent strain and damage. Make sure to use correctly sized wire nuts to properly connect electrical wires. Inspect electrical connections regularly for signs of corrosion or damage. Replace any damaged or corroded wires and connectors. Tighten all connections to ensure good electrical contact. Maintain a clean and dry environment around electrical equipment. Proper maintenance and care of an electrical panel is important to ensure its long-term reliability and safety. Firstly, inspect the panel regularly for any signs of damage, such as cracks, rust, or corrosion. Secondly, check the breakers for proper operation. Test them periodically to ensure they trip when overloaded. Thirdly, keep the panel clean and free from dust, dirt, and debris. Clean the panel with a vacuum cleaner or soft brush. Avoid using water or cleaning solutions. Finally, ensure adequate ventilation around the panel to prevent overheating. Avoid blocking the panel with furniture or other objects. It's crucial to understand the potential hazards associated with electrical work. Electrical shock is a serious hazard that can cause injury or death. Work with electrical equipment only when the power is off. Use insulated tools and wear appropriate personal protective equipment. Electrical fires can result from overloaded circuits, loose connections, or damaged wiring. Install smoke detectors and carbon monoxide detectors to provide early warning of a fire. Have a fire extinguisher readily available in case of an electrical fire. In summary, upgrading an electrical panel requires careful planning, attention to detail, and adherence to safety precautions. Firstly, assess the existing electrical load and select an appropriately sized panel. Secondly, follow all applicable electrical codes and regulations. Thirdly, use proper wiring methods and materials. Fourthly, ground and bond the electrical system to prevent electrical shock. Fifthly, protect circuits with overcurrent protection devices, GFCIs, and RFCIs. Sixthly, maintain and inspect the panel regularly to ensure its safety and reliability. By following these guidelines, you can ensure a safe and effective electrical panel upgrade.